So Elasticsearch in production is ultimately about keeping your end users happy. And if you ask your marketing departments what your users feel like, they might show you pictures of happy people smiling of salads or something. Whereas we as developers or operations people sometimes feel things aren't completely on track. My name is Alex. I work for Found. I've been working with search for most of my career. Did some database systems before that. At Found, we manage lots and lots of Elasticsearch clusters on Amazon's cloud. And when I'm not working with search, I like to jump out of planes and play with the other kind of cloud. Luckily, my parachute is a bit more stable than Amazon's instances, but it's a good idea to have a reserve or a backup plan, regardless of what kind of cloud you play with. So running lots of clusters of various sizes and high availability needs, we've seen lots of different operational challenges, but also a few misconceptions people have about running or using Elasticsearch. These fall into these categories, and while 20 minutes isn't enough to cover them thoroughly, what follows is more of an overview of things you want to learn more about. First out on memory. Memory is important not just to keep predictable performance, but also for your cluster's reliability. Search engines have a huge appetite for memory. To keep the responses as fast as they do, all the good stuff has to be in memory. So they spend lots of effort building and continuously maintaining various caches, like filter caches, field caches for sorting, faceting, and scripting. They assume your operating system has enough memory to keep hot parts of your indices in the page cache. And also building indexes requires lots of memory. Just for comparison, Postgres is extremely cautious when it comes to resource usage. If it finds it cannot do the operation completely in memory, it'll do it in steps, flushing to disk. It'll get slower, but it'll continue working. Whereas search engines, like Elasticsearch, are built for speed. They have faith in you as the user, that you've provided it with enough memory to do whatever you ask of them. So if you try to do an impossible query with Elasticsearch, like facet on a way too large field, it'll try and eventually blow up with an out-of-memory error. And when that happens, depending on what else is happening in your system at the same time, a number of bad things can happen. In the best case, your indexing or search request will simply fail. But we've also seen things like cluster state corrupted to the point where a full cluster restart is necessary. Netty has crashed, so the node is isolated. And lots of other things. So you do not want to end up with any out-of-memory error on your production cluster. Elasticsearch provides lots of endpoints that give you insights into its resource usage, like cache sizes and heap space usage. And more monitoring systems know how to use these. So you want to be continuously monitoring your resource usage. Because when you outgrow the page cache on your system, you'll see a gradual decline in performance as more and more requests will hit disk. Whereas when you no longer have enough heap space, it's more of a sudden event. You can be serving searches with great performance until suddenly some out-of-memory error causes things to come crashing down. Consequently, it's important to understand the memory profile of your searches. Say, for example, that you're tweaking your relevance model and improve some script to use another field. Then your queries needs more memory to execute, and memory usage will grow faster as more data comes into your system. So as you tweak and improve your searches in a development or staging environment, it's important to keep your data sets realistically sized so you know the true memory usage of your queries before you let them loose on your production cluster. Having memory-efficient queries is a good idea anyway, as they tend to be more performant as well. So it would be great if you could just throw lots of memory or money at the problem and just forget about it, but you can actually have too much memory on a single node. As you increase the heap space of your JVM, garbage collection becomes more expensive. And these garbage collection causes can cause impede performance, but also cascade to bigger problems. So if your heap space crosses 32 gigs, for example, you can no longer use, or the JVM can no longer use pointer compression. So we need to jump to around 48 gigs to actually get more usable heap space. And then garbage collection can become more problematically expensive. So at that point, you may want to actually run multiple nodes on the same physical machine. Test things, obviously, to find what fits your case. But ElasticSearch is built for scaling out and not up. So shard appropriately. And if you do run multiple nodes on the same physical machine, remember to route the replicas correctly so you don't have a single point of failure. So that's a lot on memory things. Continuing with security considerations when running Elasticsearch. Elasticsearch basically believes every user to be trustworthy. It doesn't have any features to do authentication or authorization. It doesn't consider that to be its job, which is perfectly fine. So we developers need to understand what we can and cannot safely pass on to Elasticsearch. And a question we often get is whether it's safe to limit access to the search endpoints of certain indices. Optionally also wrapping the queries with a filter to limit what the user can search in. And first, there's the case where a user tries to facet or sort on a too large field, causing memory problems like we've been through. But there's also dynamic scripts. Elasticsearch has really powerful scripting facilities. And while you typically use these for fancy facets or scoring, it's important to remember they're not sandboxed. So there's nothing preventing a nefarious user from doing whatever the Elasticsearch process has access to. This includes MDL, not just the other language plugins. And this is also true when you run Elasticsearch locally for development purposes. Any website can do a request to localhost and access your data or run code. So I advise running things in a virtual machine and to be careful what you have when you run things locally. Elasticsearch works great on a single node, but most people want to scale out at some point. And Elasticsearch is impressively easy to use for being a distributed system. but it's still distributed, and they tend to fail in many ways. ElasticSearch has lots of knobs you can tweak. It supports lots of different usage patterns. It can be lenient and it can be strict, or anything in between. So we need to adapt these to your needs. So this is a setup we see quite a lot. You have a node, and because you're tired of waking up in the middle of every night, you add a replica. So this is supposed to be a high availability setup. And if all you do is search, this is fine. You can lose a node, and the other one can continue answering. But if you're continuously indexing as well, you need to have a majority of nodes available. If not, you're prone to split brain situations. And a split brain occurs when you have subclusters forming, believing they're autonomous. And this in turn can lead to irrecoverable data loss. So unless you're sure you don't need a majority, configure minimum master nodes to be at least half the nodes plus one. And that plus one does not have to be an expensive, fully fledged node. It can be a cheap node that is mostly idling. And when a network partition happens, it can break the ties of the master election to ensure you have a majority. This applies to availability zones as well if you're running across data centers. If you have two nodes in two different zones, you cannot lose either of them and still have a majority. But if you run a tiebreaker from a third location, you can lose any of the three availability zones. And network partitions and instances crash in lots of different ways. It's important to know the failure modes of your underlying infrastructure. For example, if you're on EC2, they do not guarantee that two virtual instances do not have any kind of single point of failure unless they're in different availability zones. If you're on a large scale, you'll see single instances crash all the time, whereas if you're smaller, you might experience complete zone failures just as often. And when these happens, you get thundering herd effects as everybody else is scrambling to recover and repair their systems. So if you have a mission-critical system or just like to sleep at night, it's important to have your high availability set up before you actually need it. You cannot necessarily rely on a quick repair. So assuming you have a stable cluster, there are still a few things you need to do on the client side to keep things resilient and performant. Any requests with side effects should be idempotent, meaning you can retry the request if necessary. For example, if you post a document to an index and you don't get a response, you can't know whether the document was indexed, nor that it wasn't indexed. And if you leave, for example, to ElasticSearch to assign IDs to the document, you cannot retry without risking duplicates. So keep things retryable. If you use the HTTP interface, make sure your client library uses a connection pool. If not, you'll be paying for connection establishment for every single request, which is expensive, especially if you're using SSL as well. The key exchange ceremony takes a lot of time. There's a bulk interface. We see a surprisingly large number of users not using it. It's a lot more efficient when you have lots of data to index at the same time. So if you're not already using it, check it out. But do remember to actually inspect the responses of the bulk request as a single sub-operation failing will not cause the entire request to fail. There's a similar interface for searches. So if you need to do multiple search requests to satisfy your user's information need, you can use msearch and do them in parallel. So in summary, ElasticSearch provides great features at great speeds and scale. But with anything fast and fun, it's important to take a few precautions to stay out of trouble. But if you have enough memory to keep your nodes reliable, you have enough nodes to have a majority when networks fail, you carefully sanitize the request you send to ElasticSearch, and do things in a retriable way, ElasticSearch will take you really far. There should be some time for questions. Thanks for listening. I'll be available at Found's booth as well today and tomorrow. So stop by and say hi. Thanks.